What is the hybridization of the indicated carbon atoms from left to right? So hybridization of a carbon can be recognized by examining the bonds that that carbon is forming. So we will see carbon that is sp3 hybridized, carbons that are sp2 hybridized, and carbons that are sp hybridized. So what we want to recognize is that whenever we are forming a sigma bonds are formed by your hybrid orbitals. So if we have, and I'm going to draw the orbitals that we might be mixing together down here. So we're talking about mixing the s orbitals and the p orbitals of carbon. So if we are forming 4 sigma bonds, we need 4 hybrid orbitals. That means we need to mix together all 4 of these outermost orbitals on the carbon. So if we are mixing together all 4, that means we're taking 1 s orbital and 3 p orbitals and mixing them together. And we call it exactly what it is. We've mixed together 1 s and 3 p, so we call that sp3. So whenever we have a carbon atom that is forming 4 sigma bonds, it is sp3 hybridized. If a carbon is forming 3 sigma bonds, then it is sp2 hybridized, because to make those 3 hybrid orbitals, you need to mix together 3 of your atomic orbitals. So you're mixing together 1 s and 2 p, and so we call that sp2 to reflect what we've mixed together. And we can look at a similar description for sp. So from our structure, we want to just be able to recognize sigma bonds and pi bonds to identify the carbon hybridization. So if we look at the first carbon atom, we can see 1, 2, 3 bonds to carbon. So the 4th bond that is not drawn in but is implied must be a single bond to hydrogen. So for this carbon atom, we see that it has 3 sigma bonds. So 1, 2, and 3, and then 1 pi bond. Right? Whenever we have a multiple bond, you have 1 sigma bond and the remaining bonds are pi bonds. So this first carbon atom that we're pointing at is sp2 hybridized. If we look to the next carbon atom, we can see 1, 2, 3 of the bonds to that carbon. That means the 4th bond is a single bond to hydrogen. And so now that we see all of the bonds, we see we have 1, 2, 3, 4 single bonds, and all single bonds are sigma bonds. So that means that this carbon atom is sp3 hybridized. And finally, the last carbon atom is at the end of a chain, and we can only see 1 single bond. It must have 4 bonds to be neutral, so that means the remaining 3 bonds are single bonds to hydrogen. So like the previous carbon, we have 1, 2, 3, 4 single bonds. Those are all sigma bonds, so this is also sp3 hybridized.